Right now, tonight, somewhere in our own solar system, it's raining diamonds. Not a metaphor. Actual diamonds, falling through storm clouds like hail, drifting down for thousands of miles before they melt back into the depths. This is happening on Neptune and Uranus, this exact second, while you're watching this. Here's how. Deep inside those planets, methane gas gets squeezed under pressure millions of times stronger than anything on Earth's surface. That pressure, combined with insane heat, rips the carbon right out of the methane and crushes it into solid diamond. Then gravity pulls those chunks straight down. And scientists didn't only guess at this. Researchers at labs like SLAC in California recreated those exact conditions, blasting plastic with lasers to mimic the crushing pressure inside an ice giant. They watched, in real time, tiny diamonds form out of nothing. This isn't theory anymore, it's confirmed physics. I've got 20 of these lined up for you, one after another, and I promise you at least one of them is going to sound so ridiculous, you'll think I made it up. I didn't. Every single one is real, verified, sitting in actual research papers. Let's go. Now picture this. A neutron star is what's left after a massive star collapses, and it packs more mass than our sun into a ball about the size of a city. One single teaspoon of that material, scooped out and brought to Earth, would weigh somewhere around 1 billion tons, roughly the weight of an entire mountain. Remember that crushing pressure that turns carbon into diamonds a few facts back? This is that same idea cranked up to a whole different level. In a normal atom, there's a huge amount of empty space between the nucleus and the electrons buzzing around it. Inside a neutron star, gravity is so overwhelming, it crushes that empty space away entirely, until the particles are packed almost edge to edge. And here's the part that should genuinely scare you a little. There is no material, no alloy, nothing humans have ever built or even dreamed up in a lab that could survive getting anywhere close to one of these things. The gravity alone would stretch you into a thread of atoms before you got within 1,000 miles. Switching gears completely, space is silent, dead silent. Not quite like a library, I mean actual total silence. Because sound is nothing more than vibrations moving through air or water, and out there, there's basically no air to vibrate through. You could have a star exploding 100 miles from you and hear absolutely nothing. Astronauts who've done spacewalks talk about this constantly. Once they're outside the ship, floating in that void, the only sounds left in their entire world are the ones coming from inside their own suit, their breathing echoing back at them, and the low hum of the machines keeping them alive. Everything else is gone entirely. But here's the twist. NASA scientists found a supermassive black hole at the center of a galaxy cluster called Perseus, and they detected actual pressure waves rippling through the hot gas around it, basically sound, only far too low for any ear to catch. They took that signal, shifted it up 57 octaves, and turned a black hole into a tone you can actually hear. Let me stop right there for 1 second. Space does not care how big you think you are, how important your problems feel, or how much you've got going on down here. Out there, none of it registers. Not even a little. Keep that in your back pocket, because it's going to matter again in a minute. Speaking of things not working the way you'd expect, Venus spins so slowly on its axis that one single day there, one full rotation, takes longer than an entire year. It takes roughly 243 Earth days to spin once, while it only takes around 225 Earth days to go all the way around the Sun. Mercury flips the whole thing around. Its year one lap around the Sun only takes about 88 Earth days, because it's so close in. But because of the weird way it spins combined with its orbit, if you stood on Mercury's surface, a full day, sunrise to sunrise, would actually last around 176 Earth days. That's 2 entire Mercury years packed into a single day. Now think about the moon for a second. There's no wind up there, no rain, no atmosphere at all to erode anything, which means the footprints Neil Armstrong and every astronaut after him left back in the 60s and 70s are still sitting there right now, completely undisturbed, and scientists believe they could stay perfectly preserved for millions of years into the future. Here's one that sounds fake but isn't. Astronauts who spend months on the space station actually come back taller. Not by a tiny amount either. We're talking up to 2 full inches of height gained, purely from living up there for an extended stretch. Their bodies change shape in ways nobody really notices until they try to put their old clothes back on. Here's why it happens. On Earth, gravity is constantly pressing down on your spine, compressing the cushiony disc between each vertebra, all day, every day, whether you notice it or not. Take gravity away completely, like astronauts experience in orbit, and those discs slowly expand back out, pulling the whole spine longer. It's temporary, but it's real, and it's measurable. Now here's a weird one nobody thinks about. If an astronaut cries in space, and it happens more than you'd expect, the tears never fall down their face the way they would here. There's no gravity to pull them anywhere. Instead, they pull up around the eye into a stinging little ball of liquid that sits there until someone wipes it away. Switching it up again, near the center of our galaxy, there's a massive cloud floating in space called Sagittarius B2, and buried inside it is an enormous amount of actual alcohol, ethyl alcohol, the same stuff sitting in your drink, drifting out there in a cloud of gas and dust, light years wide, doing absolutely nothing for anybody, and I mean an obscene amount. Scientists estimate that cloud holds enough alcohol to make more drinks than every person who has ever lived could finish, combined, for the rest of time. Obviously, nobody's flying out there with a straw, but it's a wild reminder that the universe is stranger and messier than anything we give it credit for. Let's zoom out to something that puts everything into perspective. The sun alone accounts for about 99.8% of all the mass in our entire solar system. Not most of it, almost all of it. Every planet, moon, asteroid, and comet you've ever heard of makes up less than 1% combined. Think about that for a second. Jupiter, the biggest planet we've got, Saturn with its rings, Earth, everything. If you threw all of it into one pile, it would still barely register next to the sun. In the math of our solar system, every planet combined is basically a rounding error the universe forgot to clean up. Speaking of Jupiter, that giant swirling red storm on its surface, the Great Red Spot, has been raging continuously for at least a couple hundred years. Possibly a lot longer than that. It's a storm bigger than Earth that has never once stopped. But here's the twist. Astronomers watching it closely have clocked it steadily shrinking, decade after decade. Here's one that messes with people every time I bring it up. Saturn is so massive it doesn't seem real, but it's also incredibly light for its size, less dense than water, which means if you somehow found a bathtub big enough to hold an entire planet, Saturn would float right on top of the water instead of sinking. Mars has been hiding something bigger than anything on Earth this whole time. Olympus Mons, a volcano on Mars, stands roughly 13.5 miles tall, more than double the height of Mount Everest. It's so massive that if you stood at its base, the slope would rise so gradually you might not even realize you were looking at a mountain at all. And it's not alone. Mars also has a canyon called Valles Marineris that stretches roughly 2,500 miles long. Lay that canyon over the United States and it would run from coast to coast, swallowing the Grand Canyon so completely you'd barely notice it was in there. Mars, it turns out, does everything bigger than we do. Uranus does its own thing entirely. Every other planet spins more or less upright, like a top. Uranus rotates almost completely on its side, at an angle of about 98 degrees, basically rolling around the sun instead of spinning normally. Scientists think something enormous, maybe an object the size of Earth, slammed into it billions of years ago and knocked it over for good. Neptune is on an even slower clock. It takes about 165 Earth years to make one single trip around the sun. Neptune was discovered back in 1846, which means it only recently completed its very first full orbit since humans even knew it existed, sometime back around 2011. We've barely watched it go around once. Real quick, if this is the kind of stuff you're into, the kind of facts that make you stop scrolling and go, wait, really? I do this pretty much every day, digging up stuff most people never come across. No pressure. Figured I'd mention it while we're here. Now, back to it, because it gets weirder from here. And that's the thing about all of this. Everything up there runs on its own clock, not ours. Not days, not years, not any calendar we've ever built. Means anything once you leave Earth's orbit. Keep that in mind, because time is about to get even weirder than a planet with a backwards day. The coldest place we know of, anywhere in the entire universe, isn't some empty stretch of deep space. It's inside a nebula called the Boomerang Nebula, about 5,000 light years away, where the temperature drops to roughly 1 degree above absolute zero. That's colder than the leftover background radiation from the Big Bang itself, which is genuinely hard to pull off. Now here's one that broke my brain the first time I heard it. Light gets created deep in the sun's core through nuclear fusion, but it doesn't zip straight out. It gets bounced around, absorbed and released over and over by the insanely dense material packed inside the sun, and that process alone can take that same photon literally thousands of years to escape. But once that light finally breaks free of the sun and shoots out into open space, the hard part's over. From that point, it takes about 8 minutes and 20 seconds to cross 93 million miles and land right on your skin. So the sunlight warming your face today spent thousands of years trapped and only 8 minutes actually traveling to reach you. and that delay gets a lot more unsettling once you look at stars at night. Some of that light left its star hundreds or even thousands of years ago, which means some of the stars you're looking up at right now might not even exist anymore. They could have burned out, collapsed, or died before you were even born, and that light still hasn't finished its trip to your eyes. Sit with that for a second. Every single time you look up, you are never actually looking at space as it is right now. You're only ever looking at its past, layer after layer of old lights stacked on top of each other. That's not poetic, that's not me being dramatic, that's literally how looking at anything works. Now let's talk about something we actually sent out there ourselves. Voyager 1 launched back in 1977, and it has been flying ever since. In 2012, it officially crossed out of the heliosphere, the bubble of particles and magnetic field the sun blows around our entire solar system, and it's been in true interstellar space ever since. And it's still calling home, and it's not traveling empty-handed. Bolted to the side of Voyager 1 is a golden record, an actual physical disc loaded with sounds and images from Earth, whale calls, greetings in dozens of languages, music, a baby crying, a heartbeat. It's basically a message in a bottle for whatever, or whoever, might eventually find it drifting billions of years from now. Let's jump to one of Jupiter's moons for a second, because this one might be the most important fact in the whole video. Europa, a moon smaller than our own moon, is believed to be hiding a massive liquid ocean underneath its icy crust, and that ocean alone is estimated to hold more water than every single ocean on Earth combined, twice over. Saturn's largest moon, Titan, has its own version of that too. It actually has lakes, rivers, even rain, complete with a real weather cycle. The catch is, none of it is water. It's liquid methane and ethane, freezing cold and completely toxic to us, but structurally behaving exactly the way water does here on Earth, filling basins and carving out coastlines. Now zoom all the way out, bigger than any single planet or moon. There's something out there astronomers call the Great Attractor, a gravitational anomaly so massive it's pulling our entire galaxy, along with thousands of others, toward it at more than 1,000,000 miles per hour, and we still don't fully understand what it actually is. And here's the frustrating part for scientists. We can't even point a telescope straight at it and get a clear look, because the flat disk of our own Milky Way, packed with gas, dust, and stars, sits directly in the way. Astronomers call that blocked patch of sky the zone of avoidance, and it's basically our own galaxy hiding the answer from us. Let's lighten it back up for a second. When the European Space Agency's Rosetta mission finally reached Comet 67P, close enough to actually photograph it in detail, scientists were stunned by the shape. Two rounded lobes connected by a narrow neck, looking for all the world like a giant rubber duck floating through space at thousands of miles an hour. And that same comet gave scientists a perfect look at another rule that never breaks. A comet's tail never trails behind it like smoke behind a car. It always points directly away from the sun, no matter which direction the comet is actually flying, because it's solar wind and radiation pressure blowing that tail outward, not motion at all. Okay, let's go to Mars for a second, because Mars does something Earth could never survive. Dust storms out there don't just kick up in a corner of the planet, they go global. In 2018, one storm grew so massive it wrapped around the entire planet at once, blocking sunlight for weeks, and it straight up killed NASA's Opportunity rover. Picture a storm the size of a planet's whole surface. That's not weather, that's an apocalypse with a forecast. Here's one that's happening right now, in your pocket. GPS satellites move so fast and sit so far from Earth's gravity that time itself ticks differently for them. Their onboard clocks drift by about 38 microseconds every single day compared to clocks down here on the ground. Sounds tiny, but if engineers didn't correct it daily, your GPS would be off by miles within hours. Einstein's relativity isn't some theory up there, it's routine daily maintenance. Space changes you on a level you can't even feel. NASA ran a twin study with astronaut Scott Kelly, who spent nearly a year on the International Space Station, while his identical twin brother stayed behind on Earth. When Scott came back, about 7% of his gene activity had shifted, genes tied to immune response, bone density, even how his body processed oxygen. Most of it snapped back within months. For a while, though, space had literally rewritten pieces of him. Now compare that to the actual record holder, a Russian cosmonaut named Valery Polyakov, spent 437 straight days aboard the space station Mir back in the mid-90s, over 14 months without touching solid ground once. No weekends off, no going home for a shower. He orbited Earth more than 7,000 times before he finally landed. Nobody has beaten that number since, and honestly, nobody's exactly lining up to try. Here's the one that should scare you a little. Everything orbiting Earth is moving at around 17,500 miles an hour. At that speed, even a fleck of paint the size of a grain of sand carries the punch of a bowling ball. Flecks like that have literally cracked space shuttle windows on impact. Up there, the smallest, dumbest piece of junk turns into a bullet because size stops mattering the second speed gets involved. So think about everything we've covered tonight. Planets raining actual diamonds, worlds with 3 sunrises in one day, planets floating through the dark with no star to call home at all. Every one of those broke a rule you probably thought was permanent, and now Mars is swallowing itself in dust. Satellites are bending time to stay accurate, and paint chips are cracking windows in orbit. Space isn't just big, it's out here proving the rulebook was always just a rough draft. Alright, zoom all the way out with me, because this next part changes how you look at the night sky forever. Our entire galaxy, the Milky Way, is not sitting still. Right now it's racing toward our neighboring galaxy Andromeda at roughly 250,000 miles an hour. That's not a metaphor. 2 galaxies, each holding hundreds of billions of stars, are on an actual collision course, and it's been happening this whole time, your whole life, without you noticing. Here's when it actually happens. Scientists put the collision at around 4.5 billion years from now, give or take. When it does, the Milky Way and Andromeda won't just pass each other, they'll merge into one enormous galaxy, something astronomers have already nicknamed Milkomeda. Gravity will stretch both of them into long glowing streamers before they settle into a single galactic blob. It will be one of the biggest events the entire universe ever puts on. But before you panic about stars crashing into stars, relax, little bro. That part barely happens. Out of the hundreds of billions of stars packed into each galaxy, almost none of them will actually collide. The odds of even 2 individual stars smashing together are close to 0. The merger will look violent from the outside, completely reshaping both galaxies, while almost every single star inside just quietly drifts on past its neighbor like nothing happened. Here's why that works out. Space between stars is almost entirely empty. If you shrank our sun down to the size of a marble, the nearest star would still be sitting over 4,000 miles away. Now multiply that gap across billions of stars in 2 merging galaxies, and you get so much empty room that collisions basically disappear into the math. Galaxies can crash into each other. The stars inside barely even notice it happening. Now let's really zoom out, because this is the number that ends every argument about how big things actually get. The observable universe, everything we can possibly detect from Earth, stretches about 93 billion light years across. Light years, not miles. That means the light reaching your eyes tonight from the farthest galaxies has been traveling since before Earth even existed. 93 billion light years, and that's just to cover the part we're actually allowed to see. And here's the part that messes with people every single time. That 93 billion is only the sliver we can see. The real universe keeps going past that edge, we just can't detect it, because its light hasn't had time to reach us yet. Some scientists think it could be hundreds of times bigger than what's observable. Some think it might not end at all. We're not looking at the whole picture, we never actually have been. So here's where I leave you tonight. Every star you looked up at as a kid, every galaxy and every photo, all of it is old light. Some of it left its source before humans even existed, and it's still out here arriving, still catching up to you, right now, in real time. The biggest thing you will ever lay eyes on isn't even finished reaching you yet. Sit with that one for a while. I'll catch you next time.